let's review real quick what we did Monday and Tuesday. So this first problem is just like what we did just on Monday and Tuesday. So going through the steps, we're going to line up the equations. Now, the easiest way to do this is if it's already set up nice and easy, ready for you. You're going to look for inverse or opposite coefficients that are going to eliminate a variable. Like this first one, it's already done for you because you can see that the -6 and the +6, those are going to go ahead and they're going to cancel out. So if they already cancel out for you, just add everything else. So 5x plus 3x gives me 8x. My y's cancel out. -32 plus 48 gives me 16. And then, of course, we can finish solving. Divide by 8. We get x equals 2. And just like all of the other systems of equations we have done, remember that this is only half of your answer. Your answer is 2 comma something. So then to find the other something, you could plug it into either equation. I'm probably going to go with that second one just because to me it looks easier, but you could do either one. We do 3 times 2 plus 6y equals 48. 3 times 2 is 6 plus 6y equals 48. Subtract 6 from both sides. We get 6y equals 42. Divide by 6, and we get y equals 7 for an answer of 2 comma 7. So that's what we did Monday and Tuesday. So, and even if it wasn't set up where it was a -6 and a +6, like if it was a plus 6y and a plus 6y, all you have to do is change the signs. But remember, you have to change all of the signs in that equation, okay? Now, what we're going to be looking at today is they're not going to cancel out just as they are. You're going to have to make them cancel out. And you're going to have to do just a little bit more than just changing the sign. But it's really similar to what we did whenever we changed the sign. Okay? So, this one right here, okay? If you were to look at this one, I have 2x plus 5y equals -22, 10x plus 3y equals 22. Now, the x's, they're not going to cancel out, 2x and 10x, right? And even if I change the sign, like a 2x and a -10x, they're still not going to completely cancel out. Same thing with the y's. 5y and 3y, even if I made this a -3y, they're not going to cancel out. Not completely. What it needs to be is it needs to be like a 2 and a 2, or a 5 and a 5, or a 3 and a 3, or a 10 and 10. It has to be the same number and opposite signs. Since that's not done for me, I have to make that happen. So usually, sometimes there's going to be a pretty simple way to do this. So in this case, what I'm going to do is I'm going to try to cancel out the x's. You're going to use multiplication to do this, okay? Now, if I leave this as a 10x, so I'm not going to change the second equation. If I leave this as a 10x, what would the other x need to be if it were to cancel out? A -10, right? If this was a -10x, those would cancel out. Right? Well, here's the thing. Using multiplication, how can you make a 2x into a -10x? I'll multiply by -5. Now, this is still an equation. There's still rules. So I can't just multiply one thing by -5. I'm going to have to multiply both sides of the equation by -5, which just means I'm going to multiply everything by -5. So the -5 times 2x, there's my -10x. You have to take -5 times 5y, which gives you -25y. And then you have to take -22 times -5, which gives you a positive 110. Now, once you get to this step, now we're doing the same thing we've done the last 2 days. The 10x and the -10x, they cancel out. 3y and -25y gives me -22y. 22 plus 110 gives me 132. And then to get rid of the -22, divide both sides by -22, and we should end up with y equals -6. And just like all of the other problems we've done, that's the y coordinate for your answer. So to find the x coordinate, you're going to plug that back in. Now you actually have 3 options here. You could plug in that negative 6 in the first equation, the second equation, or if you really wanted to, you could do that third equation. But that third equation has a lot bigger numbers, so I probably wouldn't bother with that one. This first equation maybe has a little bit smaller numbers, so maybe we plug it into that one. Now remember, since it's y equals negative 6, you have to plug this in for y. So we're going to do 2x plus 5. Instead of y, we'll plug in negative 6 equals negative 22. So we'd have 2x minus 30 equals negative 22. Add 30 to both sides. So we get 2x equals 8. Divide by 2, and we get x equals 4. For an answer of 4, comma negative 6. So that one is really just one extra step. And then it's the same thing that we did yesterday. But the hard part here, probably the most difficult part here, is figuring out what variable you're going to cancel out, and then how are you going to do that. So I just decided in the beginning I wanted to cancel out the x's. So if I want to cancel out the x's, if that's a 10x, this would have to be a negative 10x, right, for this to cancel out. So to get from 2x to a negative 10x, 2 times negative 5 would give you your negative 10. So this is the negative 5 is what we had to come up with to try to get the x's to cancel out. Okay, we'll practice that more in all of these, okay? This one right here, kind of the same idea. Notice that the x's don't cancel out, the y's don't cancel out. Even if I change the sign, nothing's going to cancel out here, okay? Now with this one, what we did with the last one is I said, okay, if I leave this a 10x, maybe I can make the 4x a 10x. But using multiplication, could you make a 4 into a 10? Okay, well if you look at the y's, if you left this as a negative 4y, this would need to be a positive 4y. Can you make a 3y into a 4y? I guess not correct. And you can do a 3y and a negative 3y using multiplication. What you're going to have to do here is you're going to have to multiply both equations. So really, you can kind of just pick which variable you want to cancel out, but I will tell you one thing I look for. I know that for a variable to cancel out, the signs have to be different. And what I see is the y's already have different signs, so that's at least a start. So let's focus on canceling out the y's. So if I'm going to cancel out the y's, I need it to be opposite numbers. Remember, like a positive 5 and a negative 5, a positive 10 and a negative 10. So I'm looking at negative 4 and a positive 3. What I need to find is I need to find a number that I can turn a 4 and 3 both into using multiplication. You're kind of looking for the least common multiple of 4 and 3. Kayla? 12. Right? And you're saying, I don't want them to both be 12 because those won't cancel out. Since this is already negative, I'm going to make that first equation a negative 12y. And I'm going to make the second equation, since it's already positive, a positive 12y. See how those will cancel out? Okay. Now what you have to decide, look at the first equation. I need to go from a negative 4 to a negative 12. Using multiplication, how do you get from negative 4 to negative 12? Times 3, right? So we're going to multiply that first equation by 3. We're going to multiply everything by 3. So 3 times 4x would be 12x. Now my 3 times negative 4y, there's my negative 12y. And 8 times 3 on the right-hand side would give me 24. Now the second equation, I want to go from a 3y to a 12y. What would you multiply by to get from 3 to 12? 4. So we're going to multiply both sides of that second equation by 4. So 4 times 10x gives me 40x. My 4 times 3y, there's my 12y. And then negative 19 times 4 gives me negative 76. Once you do this step, then it's the same as what we've been doing. Because notice, my y's cancel out. So 12x plus 40x gives me 52x. 24 and negative 76 gives me negative 52. Divide by 52, and we get x equals negative 1. Which means your answer is negative 1 comma something. So we're going to take that. I would probably plug it back into one of the original equations. You could plug it into either one of the new equations, but those numbers are bigger. So I would probably prefer to plug it into one of the second ones. So maybe we plug it into that second one because there's more positive numbers there. Maybe it shouldn't matter. We'll do 10 times negative 1. We're going to plug it in for x. So 10 times negative 1 plus 3y equals negative 19. So we'd have negative 10 plus 3y equals negative 19. Add 10 to both sides. So we have 3y equals negative 9. Divide by 3, we get y equals negative 3 for an answer of negative 1 comma negative 3. Okay, so we have lots more practice to do today. Okay, let's get this glued into page 57. This is still section 6.3. We'll call this multiplication with elimination. All right, number 1. Number 1 says negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. Now the first thing you want to do is you want to make sure that you have to multiply, because obviously it's easier if we don't have to multiply. It's easier if we can just go ahead and add them, or even if we have to change the signs, it's nice if we don't have to multiply. So what you would see, if you don't have to multiply, you would see like a negative 2x and a positive 2x. Or a 7x and a negative 7x. Okay? Or a 15y, negative 15, negative 5 and positive, which I don't see. So that means I am going to have to multiply. Now, it's easier if I only have to multiply one of my equations. So what you're looking at is you're going to see, okay, if I left this as a negative 2x, would I be able to turn a 7x into a 2x? No. Yeah, there's nothing you can multiply to turn a 7 into a 2. Okay, well if I left this as a 7x, could I turn that into a negative 7x? Can you get from 2 to negative 7? That's not going to work. Okay, well let's go to the y's. If I leave this as a 15y, could I make this a negative 15? 5 to a 15? I can do that. So I kind of like to set it up so I can kind of see where I'm going. I want this to be a negative 15y. Now I can only do that by using multiplication. So how do you get from negative 5 to negative 15? Multiply by 3. So we're going to multiply that entire equation, both sides of the equation, by 3. So 3 times 7x gives me 21x. My 3 times negative 5y, there's my negative 15y. And then 17 times 3 gives me 51. Okay, now, once you do that, kind of ignore this middle equation here. Okay? Now we're doing what we did yesterday. So we're going to go ahead and add the two equations together. So negative 2x plus 21x gives me 19x. My y's cancel out. Negative 32 plus 51 gives me 19. Divide by 19, and we get x equals 1. Which, just like the other days, means your answer is 1 comma something. So you can take this, you can plug it in anywhere. As long as you plug it in for x, you should get the correct answer. So maybe we plug it in for that first one. Okay, we're going to plug it in for x. So it'll be negative 2 times 1 plus 15y equals negative 32. which would be negative 2 plus 15y equals negative 32. Add 2 to both sides, so we get 15y equals negative 30. Divide by 15, and we should get y equals negative 2. An answer of 1, common negative 2. So a lot of the ones you have to do today are going to be one extra step, and then it's the same thing we did the day before. Questions on number 1? Okay, number 2. 5x plus 2y equals negative 6, and 3x plus 6y equals 6. Okay, so the whole goal here is I'm trying to cancel out a variable. So, like if this was a 5x, this would need to be a negative 5x, which isn't going to happen, right? If this is a 2y, this would need to be a negative 2y. I am going to have to multiply because nothing's going to cancel out as it is or just by changing the signs. So what we want to see is if I can get away with just multiplying one equation because that's easier than having to multiply both. So if you're going to cancel out your x's, it would need to be a 5x and a negative 5x. I can't turn a 3 into a 5. Or a 3x and a negative 3x. That's not going to work. The y's would be a 2y and a negative 2y. Or a 6y and a negative 6y. We could make that first equation. Now remember, we want the signs to be opposites. I want that first equation to be a negative 6y. Because the plus 6y and the minus 6y, those are going to cancel out. So, how would you go from 2 to negative 6? Multiply by negative 3. So we're going to multiply that entire first equation by negative 3. So negative 3 times 5x is negative 15x. Negative 3 times 2y, there's my negative 6y. Negative 6 times negative 3 gives me a positive 18. Now we're at the same place we did yesterday. So when I add the y's cancel out, 3x and a negative 15x gives me negative 12x. 6 and 18 gives me 24. And then we can divide by negative 12. We'd have x equals negative 2. So we just have to find our y coordinate. So we're going to take this, plug it into any one of those equations, plug it into this second one right here. Make sure we plug it in for x. So we have 3. Instead of x, we're going to plug in negative 2. Plus 6y equals 6. 3 times negative 2 is negative 6. Plus 6y equals 6. Add 6 to both sides. We get 6y equals 12. Divide by 6, we get y equals 2. Okay, questions on either one of those? Okay, let's take it a step further, because why not, okay? Okay, number 3. Number 3 says 4x plus 3y equals negative 19, and 3x minus 2y equals negative 10. Now, as it is, if I left it alone, I don't have to multiply anything. The x's aren't going to cancel out because they're not the same number. The y's aren't going to cancel out because they're not the same number. So we want to see if maybe I can just get away with multiplying just one equation. If I'm just going to multiply one equation, I would leave this as a 4x, which means the second equation would need to be a negative 4x, which I can't do. Or a 3x and a negative 3x, which I can't do. If I wanted to cancel out my y's, it would have to be a 3y and a negative 3y, which using multiplication I can't do, or a negative 2y and a positive 4, which I can't do. What this means is you're going to have to multiply both equations. Now, it really doesn't matter. You can choose either variable to cancel out, but what I see that I think is going to maybe be a little bit easier is to cancel out the y's. Why might the y's be just a little bit easier to cancel out? It is smaller. That is a definite bonus. You see anything else that might make it just a tiny bit easier? They already have the opposite signs, which both of those together, I think the y's are going to be easier to cancel out. So I need the least common multiple of 3 and 2. Things that I can turn both the 3 and 2 into 6. So the first equation, since it's positive, I'm going to turn it to a plus 6y. The second equation, since it's already negative, I'm going to turn it into a minus 6y. So I can see that those are going to cancel out. So the first equation, how do you get from 3 to 6? Multiply by 2. So we're going to multiply the entire first equation by 2. So 2 times 4x is 8x. 2 times 3y is 6y. Negative 19 times 2 is negative 38. Now for the second equation, how would you go from negative 2 to negative 6? Multiply by 3. Multiply both sides of the equation by 3. So 3 times 3x is 9x. 3 times negative 2y, there's my negative 6y. And then negative 10 times 3 is negative 30. Now that step takes a little bit more work because you have to multiply both equations. But after that, it's the same. 8x plus 9x gives me 17x. The y's cancel out just like we set it up to do. Negative 38 and a negative 30 gives me negative 68. Divide by 17, and that would give me negative 4. And then the last step here, take that negative 4 and plug it in somewhere up here. So maybe we plug it into the first equation, because of course it's equals 3y. So we're going to do 4 times negative 4 plus 3y equals negative 19. 4 times negative 4 is negative 16, plus 3y equals negative 19. Add 16 to both sides. So we'd have 3y equals negative 3. Divide by 3, we get negative 1. Okay, just a few more here. Okay, number 4, and this is going to be the one that kind of takes it the furthest. This is going to be the one that's going to be the most difficult ones, I would say. Okay, let's do 3x plus 2y equals 1. And then 4x plus 3y equals negative 2. So if we kind of go through the whole steps, we first want to make sure that we are going to have to multiply, and I am, because the nothing's going to cancel out as it is, or even if I change the signs. If I want to see if I can just multiply one equation, it'd be a 3x and a negative 3x, or a 4x and a negative 4x, or a 2y and a negative 2y, and 3y and a negative, that's not going to work. Okay, so I'm going to have to multiply both equations. Now, like the last one, I'm kind of looking to see if I already have opposite signs, which I don't. So just kind of pick one of the variables to cancel out. Which ones do you guys want to do? What about the bottom one? Do what? Do you guys want to cancel out the x's or the y's? The y's? Okay, if I'm going to cancel out the y's, what can you turn a 2 and a 3 both into? 6. Now here's the thing. I don't want them to both be a plus 6y because those aren't going to cancel out. I want one of them to be a plus 6y. I need the other one to be a minus 6y, right? Because that's what's going to cancel out there. Okay? So, for the first equation, how do you get from 2 to 6? Times 3. So we're going to multiply that first equation by 3. So 3 times 3x is 9x. 3 times 2y, there's my 6y. 3 times 1 is 3. Okay, for the second equation, how do you go from 3y to a negative 6y? Times negative 2. So negative 2 times 4x is negative 8x. 2 times negative 3y, there's my negative 6y. And then negative 2 times negative 2 would be a positive 4. Then I can add because my y's are going to cancel out. 9x and a negative 8x gives me x. 3 and 4 gives me 7. And this one's kind of nice because it's already solved for me. So it's going to be 7 comma something. So take that. You're going to plug it into the first equation right there. So we have 3 times 7 plus 2y equals 1. 3 times 7 is 21, plus 2y equals 1. Subtract 21 from both sides. So we have 2y equals negative 20. Divide by 2, we get y equals negative 10. Okay, so we've got 2 more that are kind of special cases, and then I'll let you guys get started on your homework. Okay, number 5 looks like this. Number 5 says 2x plus 6y equals 18. The second equation says x plus 3y equals 9. Okay, so I already know I'm going to have to multiply because I don't have matching or opposite coefficients as it is. But let's see if we can get away with just multiplying one equation. So if I left the first equation alone and I made this a 2x, could I make that a negative 2x? Could I do 2x and a negative 2x? Yeah. Okay, what would I do with that second equation to go from x to negative 2x? Multiply by negative 2. So negative 2 times x, there's my negative 2x. Negative 2 times 3y gives me negative 6y. Negative 2 times 9 gives me negative 18. Now watch what happens when I add my equations. What happens with the x's? They cancel out. What happens with the y's? They cancel out. What happens with my 18s? They cancel out. So when everything cancels out, you get 0 and a 0 because everything is gone. So it's just 0. Okay, well, is this true? 0 equals 0. Now, be careful here because this is a system of equations. When you get a true statement with systems of equations, what does it mean? It's not all real numbers. That's with regular equations. Infinitely many solutions. If I were to graph both of these lines, what would they look like? They'd be the same line. The exact same line. Very good. Okay, last one. 12x minus 8y equals 21. And 3x minus 2y equals 5. Okay, so I am going to have to multiply because nothing matches. So let's say I wanted to cancel out the x's. Could I do a 12x and a negative 12x? What will I do with that second equation to go from 3 to negative 12? It's going to have to multiply by a negative 4 because I need to change the sign. So negative 4 times 3x gives me my negative 12x. Negative 4 times a negative 2y gives me a positive 8y. And then 5 times negative 4 gives me negative 20. Kind of like the last one, what happens with your x's? They cancel out. And what happens with your y's? They cancel out. So on the left-hand side, I have 0. But on the right-hand side, I have 21 and negative 20. When you combine those, what do you get? 1. Does 0 equal 1? No. So what is this? No solution. If you were to graph these lines, what would they look like? Remember, if you were to graph these lines, what would they look like? Parallel. Parallel, they would never cross.